Okay, so let's dive right in. We are living in a world that's basically run by artificial intelligence. I mean, these complex algorithms are making huge decisions that affect our lives every single day. Everything from medical diagnoses to whether or not you get a loan.
But what happens when we ask a really simple, totally fair question about one of those decisions? Like, hey, why was my loan application rejected? And all we get back is a kind of digital shrug.
And this is the kind of scary part. A lot of the time, even the people who built the AI don't have a clear answer. This is what we call the black box problem. You have these incredibly powerful AI systems that give you an answer, but they won't show you their work. And that's not just some technical puzzle, you know? It can lead to some really serious issues, like bad decisions based on flawed logic that we can't even see, let alone fix.
So to really get a handle on this, our investigation has to start right there, at the scene of the crime, so to speak. A critical, unexplainable decision made by a totally opaque AI.
Now, to solve this mystery, the old methods just aren't going to cut it. We need a better process, right? A much more rigorous, more transparent way to build and inspect our AI systems from the very beginning.
Let's take a look at how it's usually done. The standard process for building an AI is, well, pretty simple. First, you have the learning phase, where the model just gobbles up a bunch of data. Then, you move to testing to make sure it works. And finally, you deploy it out into the real world. Seems logical. But as we're finding out, this simple process has some pretty major blind spots.
So a truly robust process, a safer process, adds some new, absolutely crucial steps. After testing, we need an understanding phase. We have to figure out how the model is actually thinking. After you deploy it, you need an explaining phase to translate its decisions into plain English. And maybe most importantly, you need continuous monitoring to watch for things like concept drift. That's just a fancy term for when the world changes, but the model doesn't. You know, like a sudden shift in the economy could make an old loan model totally useless, and its performance just starts to tank.
And the key to this whole improved process, our #1 investigative tool, is this word right here, interpretability. It's not just about getting an answer from the machine. It's about understanding the cause and effect going on inside of it. How exactly did this input lead to that output? We need to know the why.
All right, so in any good investigation, you got to know your suspects. And in the world of AI, there are basically two main types of models we need to bring in for questioning.
On one side, you've got your white box models. Think of these as the suspects who are total open books. They're transparent, they're simple, things like linear regression. But on the other side, you've got the black box models. These are the strong, silent types. They're incredibly complex, incredibly powerful. We're talking deep neural networks that find these tiny, intricate patterns in mountains of data. But they are a nightmare to try and read.
And this right here, this is the fundamental conflict in AI today. It's a trade-off. Generally speaking, the models that are the easiest for us to understand, well, they're also the least powerful because they have to follow simple rules. Meanwhile, the most powerful models, the black boxes, get their power from their complexity, from finding all these wild connections that we can't see, which is exactly what makes them so hard to interpret.
Okay, so let's make this real. We're going to put one of our transparent white box suspects in the hot seat and see for ourselves what interpretable actually looks like in practice.
We'll use a real-world healthcare example to see how this all works. We're going to use a classic white box model called linear regression to try and predict the progression of diabetes in patients, all based on their health data.
How it works is actually beautifully simple. The model takes in patient data for different things, like BMI, blood pressure, cholesterol. For each one of those things, it learns a weight, which is basically how important that factor is. Then it just multiplies each piece of data by its weight and adds it all up. That's it. That's the final score.
Now check this out, because this is the cool part. We can literally see the model's reasoning. The answer isn't some big secret. It's right here in a simple bar chart showing those weights. We can see with our own eyes which factors the model cares about the most. And it looks like total cholesterol, glaucoma, and BMI are the heavy hitters. They have the biggest impact on its predictions. See? This is interpretability in action. No mystery at all.
So, we cracked the white box model. It's an open and shut case, right? Well, not so fast. The investigation isn't over. Because for a lot of the biggest problems we face today, like image recognition or real-time language translation, the simple power of this model just isn't going to be enough. We still need the muscle of the black boxes. And that brings us to the most crucial point of all. The future of safe, reliable AI isn't about picking the simple models over the powerful ones. It's about inventing better flashlights.
building new investigative tools and techniques that let us peer inside those powerful black boxes and finally understand what's really going on in there.
Which leaves us with one last, really big thought. As we hand over more and more of our world to these artificial minds, that fundamental trade-off between power and understanding becomes one of the most important questions of our time. How much are we willing to risk just for a slightly better prediction? It's a question that, honestly, we all need to start asking.